Good afternoon. Welcome to ITS 520. So hopefully you guys can hear me. As you know, today we're going to have our exam. During the first half of the class today, I'm just going to lecture. And then during the second half of the class, I will give you the exam. So I'll give you 2 hours for that exam. So the exam will begin at 3:30. So you'll have until 5:30. The exam, I will post it on Brightspace. I haven't posted it yet, so I will just be a few minutes before, and then you can start working on it. It's a Word document. You'll just provide your answers in there as best as you can. Okay, and then you'll submit it on Brightspace as well. So you'll have exactly 2 hours. After that, it will close, and you will not be able to submit anymore. Okay. All right. So that's the idea with the exam. The other thing I wanted to mention at this point before I forget is, before we start talking about today's lecture, is the term project. So keep in mind, currently I think it's like week 9 at this point. I haven't checked, but we only have a few weeks left. So I would recommend that you start thinking, so far you've had an opportunity to look at a few things, right? And we still have more to cover. But I would recommend that you at least start forming your groups of 3. And so groups, a minimum of 2, maximum of 3, and start thinking about possible ideas for your term project, what you would like to do. If you have anything in mind, just remember you need to talk to me about it. And that's about it. All right. So before I get started with the lecture for today, are there any questions?
Yeah, Professor, I have a question. I tried to open an account with a tutor, but they're supposed to send me API code, or you will provide us API code?
I'm sorry, I have no idea. What did you ask me? I'm sorry, what?
For the tutor assignment or whatever the homework will be?
I don't know, I don't know how that works. Unfortunately, I don't even know who the tutors would be. That's probably through some academic affairs or something like that, right?
No,
he's asking about the Twitter assignment.
Oh, Twitter.
Yeah.
Sorry, I thought you said tutor.
No.
Twitter. They didn't send you an account?
They didn't send me any codes or anything that we supposed to use, or are you gonna supply us those?
I don't supply the codes. You have to create an account. Did any of you have trouble with Twitter? First of all, I haven't assigned Twitter yet, have I?
No, I was reading on your actually.
You were just reading ahead. So no one at this point, I think, has tried this. So I wasn't really going to talk about the homework today, but
Okay.
So that Twitter, you have to have a Twitter account, and then I believe they will ask you some questions probably. But the code, I mean, it's Twitter, right? So you're accessing the Twitter API, so they have to give you. I think you have to read, how to do that online.
Oh, see, I created an API account, and they're supposed to send me something, but
yeah,
that's in 4 or 5 days. So I'm stuck getting
that. Read through it, right? So unless they've changed something recently, we've always been able to do that. So as I said, you can't download all of Twitter, but you can still download a little bit of it. The most recent week, I think.
I think they supply you a 30 code every 15 minutes. 30 tweets, I believe.
Yeah, but you have to, as I said, you'll have to go, you know, how do I create an account for Twitter API? And you'll have to follow those instructions. And then they'll give you the codes that you need.
Okay,
All right?
I'll try.
Okay, good. All right, so I don't believe I've assigned the Twitter homework yet. I don't remember doing that. I think I will probably do that next week, given that you guys are working on the exam today. So anyway, so I'm assuming there are no more questions, and therefore today I'm just gonna get into a little bit of an overview of what we're gonna do next. Okay, so if you remember, so let me switch over to the white screen. All right. So if you remember last week, I started just doing a little bit of coding. Right, so we did some coding, right? Basically we were talking about tensors. That's really all we were doing. We were looking at tensors and what they are, right? So you, at this point, you should understand that a tensor is, you know, like a vector, a matrix, some data, some amount of data, which has some dimensions, n by m, right? And these are represented as a special type of data structure that is highly efficient for matrix operations, basically, right? So as the name implies in TensorFlow, everything is tensors. All the data is represented as these tensors, and because of parallel computing, it has to be processed efficiently. So that's what we started doing on last week. We were just kind of going over this idea, okay? Now we are moving forward with, you know, these additional concepts of, you know, TensorFlow 2, Keras, which is built in. It's like a wrapper. So everything is like a wrapper of other things. You know, they're all basically coding libraries or classes that exist for us to do what we want to do. But the question is, what is it that we want to do? Okay, and so today I'm going to talk a little bit about what is it that we want to do. So there is the what we want to do and the how we're going to do it, right? So the how is this, right? The how is that. We're going to have, and as I said, you know, we're going to have to learn a little bit of the coding techniques. In particular, TensorFlow is very object-oriented. So they have addressed one, you know, that issue is very object-oriented. So we're going to explore that in more detail. But so that's the how, but there's also the what. What is it that we want to do, right? You know, what is it exactly that, why are we doing, you know, all these, the how, right? TensorFlow 2 Keras, why are we using those, right? So as I've told you before, basically what happened was, you know, you've so far the class has been machine learning, general machine learning. That's, you know, that's 520. And then 530, my 530 class, is really deep learning. And deep learning, as you know, what it is deep learning is a multitude of algorithms or techniques. You know, it's a lot of techniques that we're going to learn about. So if you take 530, you will learn about something called CNNs. You will learn about something called RNNs. You will learn about word-to-vec, autoencoders, you know, transformers, GANs, ... right? And a whole bunch of other things. right? So you're going to learn a lot of those things. Usually what I do in 5:30 is I do a little bit of an intro to just basic deep learning. You know, the basic, at the start of it is the basic idea of how do you flow from linear regression, which is something that you should be familiar with if you took a statistics course, right? And then linear regression builds to logistic regression, which builds to a neural network, which builds to deep neural networks. Right? And all of that builds to all of these, right? So it's all very sequential, right? You need to master this one so that you can understand that one, and then that one, you can understand that one, and then that one, and then, you know, and so on. From there, once you understand these basic four, you can actually jump around on these because they're just individual, you know, specific implementations of different things. So in this class, we're not going to cover any of these: CNNs, RNNs, word-to-vec, autoencoders, transformers, GANs, etc. We're not going to cover them because, you know, it's what I cover in 5:30. And in particular, this is more like the actual background of all of these. I will also cover that in 5:30. So what I'm trying to say is there's a lot of detail that goes from linear regression all the way to deep neural nets. Okay, there's a lot that goes into that. But usually that's what I cover in 5:30. 5:30 is more of a, how does it work from the ground up, from the math. Here in this second half of 5:20, I still need to cover reinforcement learning and unsupervised, right? So this little segment that I have here will be just a quick intro to deep learning. Well, actually not deep learning, just to Tensorflow, which is the language that we use in the other one. And since we have Keras, which is a wrapper that supposedly Keras makes things easier for us to do deep learning without understanding all of this, okay? So I usually don't, you know, I'm usually, so what I'm trying to say is my philosophy would be to start here, right? I like to build things, you know, from all understanding. And I say this because the approach that I'm going to take here of teaching Keras and TensorFlow will get you to do things, but you might not understand everything right away. All right, so that's the issue, that you may not understand the underlying principles of how everything works. But don't worry, because we will, if you take 5:30, we will cover all of that. It's just, it takes a lot of time to go from linear regression all the way, you know, so it takes, so that course is specific for that. If you want to understand more deeply, you know, how everything works and how to build it sort of, you know, from the first element, that will be 5:30. Here in 5:20, it's more of a top-down approach to kind of just get you started with it, okay? So I want to stress that. So I'm going to mainly then, as you can see, you know, it's really, I'm going to give you some initial code. I'll explain how the pieces fit in there without getting into too much of the details, so that we can do some machine learning with TensorFlow and Keras, even though technically I don't want to actually get into deep learning. All right, so I'm gonna probably do linear regression and, you know, logistic regression, maybe a neural net. Okay, and, you know, that's basically it. But it's going to be very much like we did it with sklearn, in a way that in sklearn, you know, all we learned is, okay, import sklearn, then from Keras import, you know, build a little bit of a logistic regression algorithm there, and then just use it, okay? And so that will be, that approach actually works out in the sense that it gets you familiar with TensorFlow, which is good. It gets you to see how Keras works, right? And then later on, as we move into, if you take 530, then you will get to understand, okay, all right, so this is how that worked, and this is how all of this works, okay? So I wanted to stress that. So the approach is not really, so right now it's gonna be a very top-down, definitely ask questions, right? But I will, I'll explain this in a more high level, right? Just to get us started before we, so that you can actually do a few things with Keras and TensorFlow. All right, so that's the plan. So I wanted to say that. So that's the, and then, the what is then therefore, just like we've done, with Weka or sklearn, you're gonna have some data set. We're gonna try to bring in MNIST and IRIS, and we're gonna do the same, some classification. My suggestion as far as the term project is concerned would be that you collect, so that you do two things. This is what I would suggest would be a good project for the end of the semester. Get two data sets. One that you found online that was interesting to you. So first of all, find a problem. So let's talk a little bit about the project now that I've given you this. So project. So find a problem, something that is of interest to you, okay? Obviously, we've seen mostly everything has been supervised learning, so I would suggest you go with supervised. Keep in mind, I will cover unsupervised at the very end of the semester, so you won't have that much time for a project. Reinforcement learning also, it'll be a couple of weeks, and so I would recommend a supervised learning problem. Find a problem, okay? Then do two things. Get two data sets. The first data set should be something that already exists. So find a large data set. We have Scholar, GPU enabled, so you should be able to run this large data set. Also, get a smaller one that you create. So create a smaller data set. All related to your problem. So it all comes from here, right? You need to identify what problem you're interested in. Once you've done that, you will, of course, follow the pipeline. So you're going to clean your data and prepare it, maybe .csv format, right? You need to identify the same thing that I've said many times, right? What are the features? What are the samples? What are the labels, right? And all stats related to this. All right, so that's gonna come from, again, your problem, right? So here you will engineer the features, right? In this one, because you're creating it. And in this one, you will already have the features, but you still need to identify what they are. Okay, you need to identify the labels, all of that. Then after that, you then perform the machine learning idea. And now you will have three tools to do it. I'm going to ask you to do this in Weka, obviously. I'm going to ask you to do it in sklearn. And now we have TensorFlow 2 and Keras. And that's pretty much what I want you to do for the project. Then you will do a presentation. So you already know how to use Keras. You had a homework, you have a homework, you know how to use sklearn. Now you're gonna learn, I will give you some code, right? I've already posted some code, as you probably have seen on GitHub. I will post more code. At least I will post one more linear regression code, and then probably one logistic regression and one neural network code, okay? I'm not gonna do any deep learning in this class, but keep in mind, pretty much if I do a neural net, I'm almost there, right? I might just, as a, given that I have the deep learning class, I don't like to, I kind of try to cover in this one a lot of what I can't cover in the other one. So I'm not going to double dip. So really, I'm just going to ask you to do like in the context of TensorFlow 2 and Keras, just again, logistic regression. Since linear regression is for a different type of data, right? So it'll probably have to be logistic regression, a neural net, and possibly, you know, if we get to a deep neural net, just a very, very simple one, which is not a big difference between these two, really. So I will provide these three scripts, basically, one for logistic regression, one for neural net, and one for a deep neural net. As you will see, they will be very similar. So that's one of the great things, is that these three are going to be very, very similar. They'll have a lot of similarities, and then you will see the slight differences. Okay, but we're not going to get into all of the details of how things work yet. That's usually something that as I said, we'll cover in 5:30. All right, so that's basically the idea. So you will use here, you know, use about 5 algorithms, just like you've done in the homework. Here, do the same, do about 5 algorithms as you've done in the homework. And then here you will use 2 or 3 algorithms. And you will see, and then of course you report the performance, right? Performance, which is gonna be precision, recall, F measure, you know, confusion matrix, and so on. This is really your project. So as you can see, your project is not that much different from homework assignments that we've done before, except that now I'm asking you to find a problem, and that you find that you have 2 data sets, one really large, and I mean large, you know, like 1 million records or something that shows you the advantage of using the GPU. So this has got to be big data. I want to stress that. Okay. And then this one, I want you to create this data set very much like you have been doing for the homework assignments. This is really, you know, in 520, that's really the point you want to drive. Okay. There are a few other things like dimensionality reduction, things like that. But when I do unsupervised, I actually cover singular value decomposition. So we'll talk a little bit about dimensionality reduction there. But really, for this course, this is the most important thing to master, okay? You have to master this entire pipeline. Okay, so as I said, find groups, form groups of 2 or 3, find a problem, run it by me, find 2 data sets, a big data set, and then create a smaller data set, all related. You'll clean your data, you know, identify these things, and then you will use the 3 machine learning. So I've given you 3 different machine learning tools that you can use, right? So you can always do the analysis with Weka, but maybe that doesn't work that well for big data. So then you try sklearn, and that gives you a little bit more control, but then you have to switch over to this to deal with, for instance, the big data problem, okay? So that's really the intuition there. All right, so now that I've given you the big picture, you can see here we can focus on this circle here, which is TensorFlow 2 and Keras. And like I said, the 3 algorithms would be logistic regression, neural nets, and deep neural nets. All right, so let's move to that. All right, sorry, before I continue, are there any questions about the project? No questions? All right, good. Seems like it's really clear. That's good. So remember, you know, you have to implement this. You have to show results. You'll have to do a demo at the, you know, the week before finals, all of that. So, you know, make interesting projects, right? You know, try to do something very interesting. All right, so now let's focus a little bit on this one. All right, so when deep learning started, right, you know, Google developed TensorFlow, TensorFlow 1, let's call it. But what happened was TensorFlow 1 had certain things that were complicated, certain things that they couldn't do, you know, they couldn't do very well. There's another tool called PyTorch. out there that has, you know, it's just another tool that you can at some point learn if you'd like, and I recommend it. You know, do it. But it's not something I'm going to cover in this class. So anyway, some people went to PyTorch because they liked this, you know, some of the simplifications of it. So that led us to TensorFlow 2. They've now addressed a lot of that, and TensorFlow 2 does have a lot more flexibility. You know, the reason why Mitch created those two GitHub environments, TF1 and TF2, is exactly for this. So when we cover the reinforcement learning topic, I'm going to use TF1. And there I'll be able to show you how things are done in TensorFlow 1 by covering reinforcement learning that way. So hopefully that shouldn't take more than 2 weeks. And then that leaves us with TensorFlow 2, which is the one that we have to, the one that we started looking at on last week. So TensorFlow 2, whereas this one was static, this one is more dynamic. And what that means is that you can actually look at everything that is happening, and you can really dig into the data, right? You can dig into, you know, at this stage, what has happened? Can I look at it? Can I maybe even modify it? So it's very good at being dynamic. It's very good at being something that you can customize more. It's more customizable, or you can customize it. All right, whatever. So you can customize it. All right, so that's basically the idea there. Okay, so now the question is, you know, how do we learn TensorFlow 2 efficiently or effectively? Okay, so that's where we are right now. Okay, that's where we are right now. So we're going to learn some coding things. So there's basically two things, which is what I was saying. There's some coding issues, and then there's the algorithms that we will learn, we will explore. Okay, so I want to give you all this context. Okay, the coding, you saw me already start to do that, and the first thing I did is tensors. Okay, tensors. The algorithms, I just talked about them. So let me actually move this a little bit down. So I want to just give you a big picture of everything. So the algorithms, as I said, the very first algorithm I will do is real algorithm, will be linear regression. It's just the easiest, simplest to grasp. All right, and then we will do logistic regression, and then a neural net, and possibly a deep neural net. Although that is getting into deep learning. So this one is the only one of these four that is deep learning. I want you to understand that. Okay. So that's it. That's as far as we will go with TensorFlow 2 in this class. Okay. Now, as far as the code, we will have to talk about a lot of things. We'll have to talk about Keras and how that works. We're going to have to talk about something called subclassing, which, you know, it's about creating a class and then subclasses that inherit the properties of something. So the way that this works is that Keras is the big class, right? That is the class that holds all of the TensorFlow models, let's say. But then you create your own. So we have the Keras class, and then you have, let's call it my class. Okay. So what's going to happen is whenever you program and develop something, you create these my classes, right? Because it's object oriented. But the my class in subclassing inherits the Keras class. Okay, so just, you know, keep that in mind. So we're going to explore that. All right. We're also going to explore a few other little things that they've added to TensorFlow now, like let's call it function painting, right? So function painting, let's say. And then there's another thing called the gradient tape, or yeah, gradient tape. So these are probably some of the most confusing things, or the newer things in the code. Everything else, I think, is actually pretty much very Python-y, very straightforward. But these are things that are new in the coding. All right, and so right now I'm just throwing the words at you. Okay, subclassing, Keras, TensorFlow, function painting. Or function decorators, sorry, not painting. I thought that name was odd. Function decorators. All right, some of these concepts are simpler. Some of them are a little bit less simple. One recommendation I'm going to make to you is if you haven't used Python object-oriented programming in a while, I would actually recommend that you just find, a tutorial online or something and become familiar with how to create simple. It's not very complex, so I don't want you to think that it's like super complex, but it is the preferred approach, okay? So you find some Python tutorials on object-oriented programming in Python. And that will help out a lot, okay? So, how to create classes, etc. Okay, so the init constructors, the call function, all of that, I would recommend that you just do a little bit of research for the next class on that. And if you do that, that will help out a lot with subclassing, with Keras, and with even function decorators. Okay, so that'll help out a lot. Then we'll talk about this oddity called a gradient tape, which, I want you to understand where it's coming from, because otherwise it'll just be a form of confusion. So this is why I give you the historical context of TensorFlow. So initially, up until like recently, like last year, this gradient tape did not exist. Was not like an established thing because you didn't really have access to it. Everything was static. So what it kind of implies is that it's like a tape, right? And as you're doing all the learning over time, imagine that you're sticking things to it, right? And so they're there. That analogy, but so what I would say is that, or the way that you can think about it is, this gradient tape would give you more access to things that are happening in real time. And that's where the name dynamic, or eager execution, whatever it comes from, versus static. Okay, so that has been one of the major changes, and you will see this in the code. Okay, and for the most part, we're not really even going to use it. This is really more of an advanced thing. So the people that really take advantage of this are people that are doing serious modifications. For our class, we are not going to be doing that much. We're not going to be using gradient. We need to have it in our code, but what I'm saying is we're not going to be fully maximizing its utility, okay? Because we're not going to be customizing. So remember, it's about making it more customizable. And so we're not going to be doing, we're not going to customize functions. We're just going to use like the very standard plain vanilla type of functions. All right, so just a little bit of information there. So certainly do the object-oriented. The other things, I think, they're basically just functions, so that's shouldn't be a problem. But that's what the coding entails, okay? Obviously, I should probably say NumPy is, it's very standard here. And then, as far as tensors and operations, I should say, that's probably. So those are that. There's a lot of coding that goes into it. Okay, and that's the how. And then there's the the what. What we're gonna do is these algorithms here. All right. So now before today, so today instead of getting into all this coding per se, I decided that I didn't just want to give you a lot of code and then have you not really understand, why we're doing things. So instead of showing you a lot of the how today, I wanted to do this. I wanted to talk about the what, and in particular, then, intuitively, I wanna discuss what are the things or the parts that all these algorithms need to have and why. Okay, so we've talked a little bit about it. So if you remember when I talked about optimization, right? So when I talked about optimization, remember that the analogy of the giant walking on those mountains, right? To find the parameters. Okay, so that's you might have, I mentioned that because that's something that has to happen in the machine learning algorithms. So all of these, linear regression, logistic neural nets, deep neural nets, they all need to have that in it. So that's what I'm going to talk about now. I'm going to talk about the parts, right? The parts, or the whatever you want to call it, the steps, or but let's call it the parts that every one of these algorithms needs to have. And then hopefully once we have a better understanding of the parts, then we will understand how to implement those parts with all this code. So then we can come back to all this code techniques and where it kind of needs to be. And I think, for our purposes for this class, what I'll try to do is make it consistent. For all four, take the same approach of where everything would be, but this is what I'm going to cover now. Now, I'm not going to really get too much into the math of everything because, as I said, that's something that I cover in 530. All right, so the 530 covers in a lot more depth, really in a lot of depth, how everything works. Okay, and how do you go sequentially from linear regression to the most advanced deep neural nets. But here it'll be more of a more high level of the parts of any linear regression or any machine learning algorithm. Okay? Any questions so far? All right, no, seems like there's no questions. So remember these things, as I said, do a little bit of, definitely, please do a little bit of research on Python object-oriented programming. All right, so let's move on then and focus now on this. All right, so the algorithms. Okay, so we're going to implement algorithms in Tensorflow. Unlike sklearn, in sklearn, we pretty much just had to create the object, then call fit with the data, and then predict or forecast or something, right? So that's pretty much what we had to do. But in TensorFlow, you have a lot more power to specify more details. Okay, so in TensorFlow, it takes a little bit more to do the same. Okay, so what that means is you still can have functions like fit, predict, etc., but you define these functions now. So they're not like built in necessarily, you actually define a little bit more of them because that gives you more control. In the TensorFlow low-level API, like in TensorFlow 1, it's literally, you could literally, like how you would do it, everything from scratch was there. And TensorFlow 2 at the high-level API, you don't go into that as much detail, as you did in TF1, but you still can do a lot more than with sklearn. All right, so hopefully that makes sense. So if we look at it, you know, in another way, from low, so let's say from low level API to high level, right? I would put Weka up here, right? Then sklearn, right? Then I would say TensorFlow Keras, right? Somewhere along there. This can be 2, let's say. TensorFlow 2 also can be more low level. And then down here was like TensorFlow 1 type of low level API, as you did things with what were called back then the session and placeholders. So I think this is a good graph. It might seem like not important, but I actually think that, you know, put this in your cheat sheet or something, because this will clarify to you why I'm going to, you know, as I said, you know, this requires a lot of coding, a lot of new things. And so you might, I don't want you to, you know, let's say that you remember that I did placeholders and sessions at some point, but then you start thinking, okay, maybe I need to use placeholders and sessions in Keras TF2, okay? So it's very important that you understand why, right? So high level versus low level, all right? And each one, even though it is all TensorFlow, each one has its own vocabulary, if you will, its own set of terms of how you do things, right? And as I said, you know, one difference is this is more dynamic, whereas down here it's more static, which means you don't have, static just means that you kind of set everything and then see the results, whereas with dynamic, it's like when you're debugging, you can actually see the values a little bit more, okay? So hopefully this will give you a little bit more intuition. All right, so we started up here, as you know, and we kind of made our way down to here, and now we're kind of here, all right? And so we'll continue going a little bit further down to about there or so, all right, as we start to go from the very high level to more low level, but still we're pretty high level in the API. All right, so that's basically the idea. Okay, so now, all right, so before I continue, are there any questions about anything that I've just said? Okay, maybe one recommendation I would do is, as you know, start putting in like the keywords, right? So create a cheat sheet and say keywords for sklearn, TensorFlow Keras, what are the keywords and the things that you do in those functions? And then, you know, so that you have TensorFlow 1, what are the, you know, when we see that. So it'll put everything a little bit more into context, and it'll help you to program. So at the end of the day, it would be nice if you can just write your code from scratch, right? That would really be the goal. However, that might be difficult. So what I'm going to do this, you know, in the next few weeks is I'm just going to give you, as I said, these 3 or 4 algorithms that I mentioned before, these 3 or 4, and as 4 scripts that you will have in Python, and then that way you will be able to modify them to use them. However, I do want you to understand things that are happening in those programs. And then as you progress, possibly when you take 530, you'll be able to understand things even more to the point where you can start writing code from scratch. Okay? All right, so anyway, so now let's talk a little bit about those algorithms. Right, so this is, we want to do, remember, supervised learning. right? Just like we did with KNN and we did with decision trees and we did with all of those. If you notice, those, I haven't mentioned those algorithms because you don't really use them in deep learning, right? So they're not deep learning type of algorithms. So instead, the ones that we're going to cover in this class are linear regression, logistic regression, and let's say a neural net. Now you have already used a neural net. What was the name of the neural net that you used, and what was the name of the tool that you used before? So you maybe don't even remember, but you did use an algorithm that was a neural network. Anyone remember the name? You don't? What was the name of that very slow program or algorithm that you used in Weka? Nobody really? All right, so that was the multi-layer perceptron, right? So if you remember, the multi-layer perceptron was it wasn't logistic. It was the multi-layer perceptron. That's something that you used in the Weka program. Anyway, so now we're just going to do this, you know, with this new tool. So what is the difference between, first of all, we're going to group these into, or identify what they predict, okay? So linear regression does not predict classes, all right? Linear regression actually predicts real valued numbers. And I'll write here, not classes. So for instance, linear regression would not be good for the iris data set. The iris, you wanted to predict, given a sample of 4 features, whether it was one of 3 things, setosa, virginica, or versicolor, right? So you've done that in Weka. Linear regression is not for that. Linear regression is for the kind of thing where you want to predict, you know, given a value, another value. So for instance, if I give you square footage of a house, I want to get the housing price, right? So what is the price of a house given that I have, you know, square footage, the location of the house, etc. But it predicts real valued numbers. Whereas logistic regression predicts classes, right? So logistic regression predicts classes or labels. All right. So logistic regression you've used before in sklearn, I believe we used it, and it's basically for predicting, you know, specific classes. So this is where we use MNIST. So we use, you know, this is for MNIST, the iris data set. Oops. So MNIST, iris. So this one predicts labels, you know, iris was setosa, virginica, versicolor. MNIST was 10 classes, right? So 0, 1, 2, ... 9, right? So keep that in mind as well, okay? That's what we're predicting. Given something, we are predicting something. And then a neural net, actually neural networks, usually we're going to use them for labels, but they can predict both, right? So a neural net could predict, you know, both, let's say. You know, the way that we can build them. So, but mainly we're going to use them for labels as well. All right, so that was the first thing I wanted to say. So then the other thing I wanted to say now is each one of these algorithms will have a certain number of parts. And that's really where, you know, where I kind of want to go with this, because that takes us into the how we're going to do this, okay? So at a very high level, I'm going to say for these algorithms, okay, linear regression. So before we get into the code, you know, I wanted to do this logistic regression. And I want to make sure that you understand why. Oops, we're doing this. So these are algorithms, okay, which means they have parts, you know, but they have a specific objective, which we already talked about, right? The objective is to predict either a real valued number or a label given some data. So one of the most important equations in machine learning is basically a simple equation from algebra, which is, you know, something you learn in high school, right? You know, the equation for a line. Okay, that's really what I want you to understand. All of these have as their underlying principle this, okay? This equation. So in all of our algorithms, we are going to write that equation. You know, that's the thing that needs to be in everything. Why do we need that one? Because remember, X is what? The input is the data. So for instance, X would be the, you know, the data that we give it. We train a model and the model learns, oops. We train a model and the model learns M and B. And then once the model is trained, which means it has learned M and B, when we give it another X from the test set, it's going to predict Y, and that gives us our value. So everything starts at Y mx plus B, Y mx plus B, Y mx plus B. Okay, that's really what you have to understand. This is usually called the inference function. And usually when I write the code, sometimes
Professor, could you please just explain a little more about the equation of the line?
Say that again, sorry?
Could you explain a little more about the y is equal to mx plus b and how we, you know, predict the y?
How does y predict?
You said that we train the test data and it gives us the y.
Yes.
If you could explain me a little bit more about that.
Okay, so if I have a function, what, you know, it's any equation, right? So if I have, you know, what's in, you know, housing price, okay? And I want to know, so this is the square footage, square feet. And then this one is the price, okay? So I need to find some kind of relationship between the data and the price, okay? So for instance, let's say that square footage goes up, and then the housing price, I'm just going to say K here, goes up. Would you agree that that makes sense? If the square footage goes up, the price goes up, correct?
Okay, got it.
Huh?
Yep, I get it.
Yeah, and so therefore, the question is, how do you capture that in just one equation? You see that? So that's where the M plus B comes in, because those two parameters will capture that. Do you see that?
Okay.
You figure out the value of M. M is going to be a value that, oops, a value that changes. So if I make this 10, because I discovered that the parameter should be 10 and let's say B was 5. You know, that it always has that little offset. So this relationship gave me that 10. So it's proportional, right? As X increases, Y increases by this factor of 10.
Yeah, it's directly proportional.
Exactly, it's directly proportional, which in graph form would mean what? If this is square footage, if this is square footage and this is price, what does that line look like?
The square foot increases, the price also increases at the same time.
Yeah, so think about it. So, you know, let's just say if it's 2, then Y is 10, right? And if it's 4, then it's 40, right? And so you can see a line that kind of looks like that, correct?
Yep. Got it. Yep.
Make sense now?
Yep.
If 10 was 1, you know, what does that mean? If 2 is 2, what is Y? Assuming this was 0, just to simplify things. This one's 2, right? So it just becomes a line sort of like that. So you're capturing that relationship, okay?
Yes, sir. Got it.
Does this answer your question?
Yes, it does.
Okay, great. All right, so it's a good question, actually. And all of these algorithms try to start at that function. However, as you might imagine, each one will add its modification to it, okay? Right, so that's something that's really important. Okay, so linear regression is the simplest one. We also rewrite the terms, and we're going to say actually y equal wx plus b. Okay, so we're going to call the m's w's, which basically means weights. Additionally, this only represents one feature, but Iris has 4. So we rewrite that even further by saying w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 plus b. Do you see that? So you can see how we started that equation and we just expanded it a little bit, but it's still the same idea. Because what I just did of the graph here in 2 dimensions holds for, so this would be R2, right? 2-dimensional, but it also holds, it also holds for this one, which is R4, because I have 4 features with, you know, a space with a dimensionality of 4. Is that clear, guys?
Yes.
Okay. All right. So look, in here, remember the values are real valued numbers. So it always predicts a real valued number. Logistic regression, on the other hand, is very similar. You have that, except that now we need to predict labels instead of predicting real valued numbers. So we're not going to predict anything from, you know, minus infinity to plus infinity, right? Any kind of value in there, but instead we predict labels. So for instance, just remember Iris, only 3 classes. So we need to make a modification to the function so that it does that for us, okay? And so that's where we're going to just, so right now I'm just going to say, you know, we're going to have this one gets rewritten as W x plus b. Instead of writing w1, x1, w, you know, I'm just going to do this. Okay, and that just means that they represent vectors. Okay, so they represent vectors, but they basically, you know, that means that I have a w1, w2, w3 until wn, you know, and so on. So this kind of means w vector is w1, w2, dot, 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 wn. right? And x, kind of the same thing. It's x1, x2, dot, 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 xn, and so on, right? Dot, dot, dot. Right? And then this c now, to get to y, needs to go through a function. All right, so we're gonna run. So notice that the modification is not really that big. Okay, notice that the modification is not really that big. Okay, we start pretty much with the same thing, but then we just had like an intermediary variable. Then we run that intermediary variable through a function, and then we get the y. And what this function will do is that anything that's a real value will get compressed into just one of three values. Do you guys see that? So that's what I'm doing there. With neural networks, it's sort of the same thing. We define, this value. As you can see, they all build on top of the next. But now we have an additional thing. Instead of just having directly to y, now we can do the following. We can do that c now, we're going to run it through what is called a layer of c that gives you hidden 1. And then we can have another layer that takes that hidden 1, notice, and gives you hidden 2. And we can continue doing that as many times as we want. If we do that more than once, that is called a deep neural network. So for instance, here, if it's just 1, it's just a neural network. If we do it more than that, it's a deep neural network. And that is literally the difference between deep learning and just plain neural networks. All right, and then we keep doing this until we arrive at the last one, which would be y function h, let's say n. And that's it. Do you see that, guys? Now don't worry, as I said, in 530, I go into all the details of how this works, okay? And we're gonna code it, as much as possible like this to understand the algorithm. But here, I still want you to have a sense of what we're doing, right? And I want you to understand that we always need to have the prediction function. So we start at this function here, and that's the inference. So just maybe a inference. Okay, that's the inference. In linear regression, you really just have this and you predict that. So remember, linear regression, you have that function, you predict real valued numbers. In logistic regression, now you need to convert the real valued numbers into classes. So, I sort of added that little function in there. And then also, and that's it, basically, right? And then for the inference. And then in the neural nets and deep neural nets, they're still the same. They still have this function, right? And the function gives you labels, 0, 1, and 2, except that in between, now you have this idea of layers. You see that? Are there any questions about this? Okay. Another way of viewing this graphically could be like this. So if we have linear regression, logistic regression, and neural nets. Another way of seeing that is that we have neurons and we're predicting like that, right? So the weights are just the connections. So if you look, that's that, right? We have x1, x2, x3, x4 times w's, and that gives you the y. So that's sort of x1, x2, x3, x4, x5. These are the weights, w1, w2, w3, w4, w5, and that gives you the y. You perform a matrix multiplication, basically, on it. With logistic regression, we do sort of the same. I'm going to use 4, right? And now, given that we have labels, we have these labels, right? Instead of a real valued number, we want to have, let's say, 2 labels. All right? But we want these labels to be, instead of, 35, 37, real valued numbers, they're just going to be classes. So for a 2-class problem, we have, class 0 and class 1. You're going to have to represent it in another way called a one-hot encoded vector, which basically means that, that's the first class, and this is the second class. Okay, so we do it sort of like this. All right, and so that's the representation here. So now we have you see that? We have more, these are still the x's, x1, x2, x3, x4, and these are all, let's just say all the weights. And then here we have y1, y2, but they're basically the label because it's going to be one-hot encoded, but they translate into the class, setosa, versicolor, and so on. Is this clear?
Yes.
All right. Another thing is that if you notice, on here, there was this idea of a function. So I'm just going to wrap this around a function. Right? So that is to say that when I get to y, before I get to y, that value needs to pass through a function. Okay? Now the neural net, then what is the neural net? Let's go back to what I wrote over here. Okay, we still start at this. But now and I still have the function here. But I'm saying that I'm running through several layers, however many layers as I want, because I just get the original z goes there, then I get h1, and h1 is to the second layer, then I have a h3, and that's h2, right? And so on. And what we're doing there intuitively, it means that we're giving more processing power. We're modifying, filtering, whatever you want to call it, the data more and more so that the neural net can learn even better. Okay? Since this is not a deep learning class, I'm not going to talk about any of that right now except to give you this contrast. And so how does that translate graphically? With the same analogy, 1, 2, 3, 4. So it's x1, x2, x3, x4, right? And then over here, we still have, let's say, the same 2 classes.
Professor, these x's are the data set?
Yeah?
The x's are the data set, right?
Yeah, x's are the data. Whenever, ever, I use the letter x, I mean the data, okay? Always. And y is the predicted value.
Got it.
Okay, so for instance, that's why iris and MNIST are introduced so early on, so that whenever you get confused, x is the 4 features in iris, and y, oops, not there. And y is what? setosa or virginica or versicolor, right? One of the three classes. Always, always, always. Any other question?
No.
All right. And then the only difference here is because we have this idea of these layers, right? So we have these layers here. We got to introduce that as well. And so that means we just have, I'm just going to do 2. And you have layers in between. So now look at all the connections. I'm not going to do all of these because it would take me all day. And imagine how much computing power you need to do this. You see that? Imagine now make all of those connections. And that's why this is called hidden 1, hidden 2. This would be the input, as you know, and that's the output. And these are the y1, y2. And remember, these pass through a function. You see that? However, these can also pass through functions. Why not, right? And usually these are called activation functions. Both of these, the outer rectangle, are the activation functions. So you will see me possibly in some of the code example, even though we're not going to do any, this is actually a deep neural net. I just want you to know. That's a deep neural net of 2 hidden layers. For this to be a neural net, it would have how many layers in between? Just 1. Okay? You will see that these activation functions have many names. The most common activation function is called a ReLU function. So you will see that. Right? So these are all the pieces of the puzzle that we have to build. Okay? These are going to be all the pieces of the puzzle. So let me do, I guess for completion, a neural net then would be, oops. Just 1. You know, imagine all of these are connected, okay? I'm not going to connect all of them. It only has 1 hidden layer. These are x1, x2, x3, x4, y1, y2. They go through a function. Before you give the final output, you run that through a function. And this can also go through a function called the activation function. That could be a sigmoid function, tangent, ReLU. Don't worry about this. For now, as I said, if you take 530, we'll cover that in a lot of detail here, not so much. But basically, that's a neural net that you're looking at there. And this is a deep neural net. It's got, as you can see, it just has 1 more layer. Logistic regression, linear regression. If we look at it from the code point of view, this is a deep neural net because it's got multiple layers. If it only had this one, it would be a neural net. Okay? Now, keep in mind, all we have defined so far is called the inference and architecture. All right? However, okay, so that gives you, so hopefully that makes sense, okay? Because that's important that you understand this. Now, as I said, because later on I have to give you the code and we have to basically write all of this into our scripts. So now the trick is, if you remember, how do we learn? How do we learn? Because I'm defining a function like this, and I know these values, but how do I learn these? These are called the parameters, the weights. And usually this is learned through optimization and in particular gradient descent. So if you remember, I covered this a few weeks ago when we talked about the giant walking through the mountains, right? So if you don't remember how that worked, go back to the video, but you can see there, you know, we talked about that. This is how you would find the weights, okay? So as I said, if you don't remember that, go back to those videos, make sure you understand that. So we still, in our code, are gonna have to, we're gonna have to account for that. So again, now, we go back to linear regression, logistic regression, and neural nets. Okay? So now, what are the parts of our algorithms? The basic parts are going to be the inference, which I already defined, that equation, the loss function, calculating the gradient, or let's call it the optimization, actually, better name. Optimization and validation. They all have pretty much the same one, the same steps. All of them have the same steps. So inference, I already defined for all of these. Right? Define, define, define. Inference just means these, right? So that's the inference. Defining the equations that we're going to be using. Okay? So now what we have to do is we have to define the other parts. They have to be in there. The validation, if you remember, we already have from sklearn. All right, we already have this from sklearn when we did that function, print metrics. Right, so print metrics. We already have this. So this is where you do like accuracy, F measure, you know, precision, and so on. That's the same for all of these. So just write the initials here. They all have the same things. I want you to understand that, okay? They all have the same thing. They all have pretty much the same optimization. They all have the same optimization. All right, they all have the same optimization, which is usually it's just going to be gradient descent. Oops. Gradient descent. Gradient descent. Gradient descent. They all have that. And it's always usually going to be the same thing. So all we have to do is we have to learn how to code this. Okay, so I want you to understand one of the things that we're going to learn how to do is how to code for that. Okay, and that varies. The way that you code it in TensorFlow 1 is different than the way that you code it, you know, for TensorFlow 2 and, you know, and variants of that within Keras and so on, okay? So there's certainly a lot of ways that you can do it. But for the most part, they're going to be the same. So my point is, these are the parts that every algorithm will have and that we must learn how to code for. So I didn't just want to start giving, that's why I did this lecture today, because I didn't want to just start giving you a lot of code and then you don't know where it fits, okay? Instead, what I'm doing here is I'm giving you the parts so that you know then, okay, this is why we're doing this part, this is why we're doing this part. As we train all these algorithms, we're going to have a for loop. All of them are going to have a for loop. I usually call it the main loop. And it's a for loop that basically what happens there is in that for loop, you grab a batch of data. So it's a for of batches. A batch of data just means if you have a 10 million records, you can't load 10 million records into memory, right? And so what I'm gonna take until 3:30, guys. So I need 8 more minutes. So instead of taking a million records, I'm just gonna take like batches of 64, batches of this, batches of that, right? And every one of these algorithms will have this for loop. So I grab a batch, and what do? The batch is the X's and the Y's, right? So hopefully you understand that, just like we've done before with train and test, except that now we're just gonna slice a little batch of the entire data set instead of giving it the whole thing. So we're gonna take that batch and we're gonna feed it into these parts, right? We're gonna feed it into those parts so that we can start training the model. We give it some X's and Y's, and the model starts to infer and starts to create or figure out the parameters, the weights, and the biases that it must learn. Now, the question is, how is it going to learn? There's got to be something that it's trying to optimize. We know that the algorithm to optimize is to do this search, right, in the mountains. But if you remember, again, go back to the optimization function, we said that this equation could look like this, right? It could look like that. Or it can look like this one. This is, they're both, different kinds of functions that you're trying to optimize in the optimization space. So that takes us, if you remember from that optimization lecture, we actually ended up having 2 equations, right? We had the inference function or equation, and then we had the optimization function. So for this class, we are mainly just going to explore the linear regression optimization, which looks like that. And if you remember, the equation for that was y minus y hat square, right? And the sum of that, and we wanted to minimize. However, there's also the log function. There's a log function, and the log function usually looks like that. And that one is actually 2 graphs. And the other one, I think, looks like that. And so whereas this function looks like that, the log function looks like that. Okay? And for our purposes then, this loss function will be that quadratic one, right? And for these, we're just going to use log functions. Okay? So it's another, I'm kind of running out of time here today, so I still need to talk a little bit about this, but for now, I just want you to understand the parts, right? That when we write the code, we need to define an inference function, the loss function, the optimization, and the validation. All right, so generally these 4 parts will appear in all of our algorithms, okay? And so we know that we need to have them in there, and so we're going to have to code for them. We're going to have to learn how to code them. So usually this will be the quadratic function. This is the log. It's called a cross. This is actually called a cross entropy, and it's a little bit more complex than just log, but I just said log. Okay, so I'll pick up here next week, okay? Because given that you have your exam starting soon. So again, all I'm doing is I'm giving you a high overview of what every algorithm needs to have. It needs to have a way to predict, but then it also needs to have a way to learn those parameters, right? And the way to learn those parameters is done by defining these. And for our purposes, we're just going to use two loss functions, which will be either the linear regression function or the, I should say, the cross entropy here instead of log. The cross entropy. Okay? Keep in mind, we usually, all we have to do when we're defining these is we have to use the built-in Tensorflow function. So it's basically like we're saying, okay, learn this equation, right, the inference, based on some other optimization objective, which is, in our cases, will be the cross entropy. Okay? And so those two things need to be mentioned in the code, and you will see as we start coding it. However, I haven't at this point at all described what cross entropy is, so that's something else that needs to be addressed. Okay? So anyway, so hopefully this gives you an overview of how the algorithms work, and then now that you understand these parts, you can expect that they will be in the programs that we're going to do in the future, but they will be pretty similar. You will see that, you know, there's a little variant here and there, but for the most part, they all have the same pieces. Okay? All right, so I'll stop here. Digest this video when I post it, go back to it, you know, try to ask questions. And then we'll pick up here next week. And then hopefully, once I do that, we'll be able to get into the TensorFlow 2 code and Keras and all of that. All right. Any questions? No questions, really? All right. So if there are no questions, then what we're gonna do now is I'm going to just you're gonna have the exam from 3:30 to 4:30. What I will do is I will sign off, and as soon as I sign off, I will post the exam on Brightspace. You'll see a new module that says midterm, and then just start working on it. And remember, the link will close in exactly 2 hours. Okay, so the exam is from 3:30 to 5:30. Okay, is that clear?
Yep.
Okay, great. All right, so I'm going to sign off. I don't want to waste your time, so I'm going to sign off and expect the exam to appear in about 2 minutes, okay? All right, I'm going to close here.